All right, welcome to the 27th episode of Swish, creating a closure with Claude code. It really is becoming a closure, more than I had initially thought in the beginning. But anyway, here are the things that we have done since the last video. So we've got all these functions. And the big feature that we have is multi-methods. And I will do a demo of that later. With precision, with the math context bounding, we're only supporting one rounding mode in that because that's the big decimal, big integer library that we're using on Swift only supports that rounding mode. And for all the discrepancies that there may be, you can always look at Claude.md. Big message also that we're now passing the Jank Clojure Test Suite. 0 skips, failures, or errors. We also added a Swift persistent list to do some performance improvements. So all lists are backed by Swish persistent list. We also updated our copy of the Jank Clojure Test Suite. There were like 23 new files and some more tests. We addressed all those issues, and we still have no skips, errors, or fails. And then talking to Claude and analyzing the code, I was trying to do some performance improvements, address discrepancies. It found more functions that the Jank test does not cover, quite a bit. So we've got all these other functions, or regular expression stuff, exception stuff, con functions, threading functions, map functions, all kinds of stuff. Additions to closure set, and there's a now closure walk, which I forget is what's that is used for. We've got the set form for setting dynamic vars, and doesn't work on def type fields yet. The reify function for interfaces, protocols, more regular expression functions, and we extended our protocols to work on built-in types that we have, like int and double and whatnot. So I will be continuing to address performances issues and discrepancies that we have and that are noted in Claude.md. Continuing to try to get things as close to closure as makes sense, and also make the performance as good as possible as well. And then eventually we'll work on an embedding AI API, and then we can show you Swish in action in actual Swift apps. We could do that now, but I won't concentrate on that until then. So anyway, I wanted to show a demo of the multi-methods. So here's the demo we got. That's just similar to other demos. Here we're showing def multi and def method dispatching on an arbitrary function of args. So here we're dispatching on the type function. So we define a method for circles, an area method for circles that uses pi r squared. And then we also have one for rectangles, width times height. We're just printing out what the multi-method is here. Then we're actually calling the multi-method on a circle and then on a rectangle. And if we run that, you can already kind of see it, but let's run it again. And so if we go to the top here we are. We get the area for the circle and the area for the rectangle. The next section is no matching method, and there's no default, so it throws. So we call area on a triangle, and it throws an exception, and you can see that doing here. We're catching the exception and printing it out, returning the string. No method in multi-method area for dispatch value triangle. Now, if we add a default multi-method, it just, and we call it on the triangle, now we get a known shape as we defined it to do. We also have hierarchies with derive and such. So here we're deriving square from rectangle that we defined above. Printing out the result. Is square a rectangle? Yes, it is. Asking what the parents of square is, and we get a rectangle. Ancestors of square, a rectangle. Descendants of a rectangle, square. Here, next we have a multi-method dispatching on the hierarchy. So we define a multi-method called the describe shape that dispatches on identity. Now, and then we define one for rectangle, and it just returns some kind of rectangle. We define one for square that returns specifically a square. Now we print out the result of describing a rectangle, sometime a rectangle. We do the same thing for square, and it prints out what that method matches the more specific square method. Describe shape square, which then prints specifically a square. Let's see, ambiguous dispatch. So we define a multi-method called combine that just returns the argument. We derive spork from spoon and spork from fork, and then we define a combine for spoon that returns acts like a spoon. We're printing the result of those. And we get the result. An error, looks like. And then we have prefer method, which resolves the ambiguity. So we call the prefer method for combine and for spoon and fork. I haven't used this method. So we print out the result of prefer combine spoon fork, which I guess returns act like a spoon. And then we call prefers combine, and that prints out user spoon, user fork. Multi-arg dispatch on a function of all the args. So we define a collide multi-method that takes two arguments and returns a vector of those two arguments. That's dispatch function. Then we define a collide method that dispatches on spoon and fork and will return clink. So when we call collide, it returns clink. Lastly, we have introspection on the method. So if we get all the methods for area, we get the circle. There's a circle one, there's a default one, there's a rectangle one. We get the method for circle. We can get the method for area hexagon, which doesn't exist. So it falls back to the registered, which is just fn. If we call get method on collide, there's no match and no default. You can remove the method on the circle method for area, and then we try to get it, and it falls back to the default. And then if we say remove all methods, and then we get the methods for combine, we get empty. And last, removing a default is idempotent that does not wipe out methods already installed by def methods, or reloading a namespace during development is safe. So here we create a multi-method called greeting that dispatches on lang. We define a greeting method for the English language that just returns hello, and we define one for we redefine it, the multi-method on lang, and then we call greeting again, and we still get hello. And that's it. That's the demo for the multi-methods. We are up to this point. We are up to 3,395 tests in 211 suites, and it executes in roughly 6.6 seconds. It's gone up as high as I think 12 seconds, and I had to get that down further. And a lot of these tests mirror what is in the Jank Clojure Test Suite, and you can also run that. It takes a little bit longer. There's some slowness around concurrency testing because it has to wait for things and whatnot, as well as testing stack recursive methods and stuff like that. So it's got to go through some large number of things sometimes for some of the tests. And the unit tests kind of lower those to a reasonable default, where the Jank unit test, user test, does not. So while we're waiting, like always, please like and subscribe, comment below whether you like what I'm doing, want to see something different, questions, whatever. And you can also buy me a coffee if you want to support my work. I would really appreciate it. And also, if you want some help with some development, I'm available, or even just some consulting. Let me know. All right, so there's the Jank Clojure Test Suite is finishing. So again, going forward, we're going to continue to address discrepancies between Swish and Clojure, improve performance, and then at some point, we're also, part of that is finding missing functions that we still need to do, and then at some point we'll start working on the embedding API. Until next time.